Good morning, students. In our last video, we have completed types of motion and the topic objects having more than one type of motion. And I have left one topic, that was pendulum, which we will see today at the last. Now we are going to start our next topic, scalar and vector quantities. Our topic is scalar and vector quantities. Now, as we have studied in the first chapter about physical quantity, the quantity which can be measured is called physical quantity. Now that physical quantity is divided into two categories. First is scalar quantity and second is vector quantity. Let us see what is scalar quantity. First we will see scalar quantity. First we will see the definition. The quantity which have magnitude but no direction. Those physical quantity which are having only magnitude. Magnitude means value, which are only having value, but it don't have any direction. But it does not have any direction. For example, we will see, for example, mass of an object, length of a line, then after time, density. These are the example of scalar quantity which is only having magnitude. It means only value is there, no direction is there. This type of quantity is called scalar quantity. Now just opposite to it, vector quantity. Next we will see vector quantity. First we will see the definition. The same we will write. The quantity which has magnitude as well as direction. Those quantity which are having magnitude as well as direction, they are called vector quantity. Let us see some example. For example, displacement, then velocity, acceleration, weight, momentum. These are those physical quantity which are having their value also, and they are working in a specified direction. Next we will see distance and displacement, and we will get some more detailed concept of scalar and vector quantity in the topic distance and displacement. Let us see first distance. Distance and displacement. Let us see first distance. The definition of distance says that actual length of path is called distance. The definition of distance is actual length of path is called distance. Suppose a boy is started traveling from point A and he wants to go to point B. Now he moves first this side, then he went like this, then he went like this, like this he reached to point B by traveling C, D, E, F, and like this a boy has traveled from A to B. Now how we will calculate the distance? We will measure the length of path, that is AC plus CD plus DE plus EF plus FB. This is the measurement of length of path. This will be called as distance. But if we talk about displacement, if we are talking about displacement means shortest distance between 2 points. We can say shortest distance between 2 points. Now, in the same example, if that boy wants to go from A to B, what will be the shortest distance? This will be the shortest distance. If he travels in a straight direction, he will reach, but in distance no direction is there, no fixed direction is there, but in displacement there is a fixed direction. The displacement means shortest distance between 2 points. Distance, it is a scalar quantity because it has value, but it don't have any direction. See here, we can see that direction is not fixed. But in displacement is vector quantity because it has magnitude, the value will be there, the length will be there, and it will travel in a specified direction. This is the main difference between distance and displacement, and by this also we can understand scalar quantity and vector quantity. Let us move to our next topic. Next we will study speed. First let us see the definition of a speed. We can define speed as a speed of an object is the distance traveled by it in unit time. Definition of speed says speed of an object is the distance traveled by it in a unit time. The formula for calculating speed of an object is distance traveled by time taken. This is the formula of speed, and speed is also a scalar quantity. It is also a scalar quantity because speed has only magnitude, that means value, but it do not have any direction because speed is calculated according to the distance, and distance is a scalar quantity. That's why speed is also a scalar quantity. Speed tells us that how fast and how slow a body is moving, and we can calculate the moment or the speed of the body by this formula. Now suppose if a body, let us understand it more clearly by an example. Suppose if a body has traveled some distance, that distance is 100 km, and it has taken time of 2 hours. Suppose distance traveled by a body is 100 km and time taken by body is 2 hours. How we will calculate speed? We know the formula, speed is equal to distance by time. Distance is 100 km and time is 2 hours. 2 5 ja 10, 0. Speed is equal to, we will write 50 km per hour. Kilometer per hour. This kilometer per hour is the unit of speed. You can say that unit of speed is kilometer per hour. Kilometer per hour is the unit of speed. This is the biggest unit. The smallest you can say meter per second. This meter per second is the SI unit of speed. Meter per second is the SI unit of speed. And we have discussed now that speed is a scalar quantity. Why? Because distance is a scalar quantity. Now in place of speed there is one more term, that is velocity. Next we will see velocity. Speed and velocity both are same term, but they are calculated on different basis. Velocity, the formula for velocity is displacement by time. The formula for velocity is displacement by time. As we know that displacement is a vector quantity, that's why velocity will be also a vector quantity. It will also be a vector quantity since displacement has direction. That's why velocity will be also having direction. Let us move to our next topic, uniform and non-uniform motion. Uniform and non-uniform motion. By its name, uniform means same. As you all know that the school dress is known as uniform because all the students are wearing the same type of dress, that's why it is called uniform. Here we will study the same term, uniform and non-uniform motion. Let us see first, that is uniform motion. Uniform motion says that when a body covers equal distance in equal interval of time. When a body covers equal distance in equal interval of time, then that type of motion is called uniform motion. That type of motion is called uniform motion. Like, let us understand by a diagrammatic form. Suppose a body starts from point A, it travels point B of 10 kilometer in 20 minutes. Then again B to C, again the distance is 10 kilometer and again the time is 20 minutes. Again from C to D, again distance is 10 kilometer and time is 20 minutes. Now we can see that from traveling from A to D, the distance between we have taken two point which is in the middle point, and we can say that for traveling a body from A to B, distance is 10 kilometer and the body is traveling in 20 minutes. Again the next 10 kilometer taking the same time, the next 10 kilometer again taking the same time. This type of motion will be called uniform motion, equal distance in equal interval of time. Similarly, non-uniform motion in which same distance in unequal interval of time. If a body covers same distance, it means distance is same but time interval is different. We can say that A, B, C, D, E, F. A body has to travel from A to F. Certain points we have taken B, C, D. Suppose every point the distance is 5 kilometer, and in every 5 kilometer the time duration is different. Here body takes 5 minutes, here body takes 7 minutes, here it takes 10 minutes, here it takes 2 minutes, here it takes 3 minutes. We can see that the distance is equal but time interval is different. Then we can say that the body is in non-uniform motion. One more case we can take, unequal distance in equal interval of time. In this case, the time interval, let it be equal 5 minutes, 5 minutes, 5 minutes, 5 minutes. The time interval is equal and distance in first 5 minutes it travels 5 kilometer, second 5 minutes it travels 7 kilometer, third 5 minutes it travels 3 kilometer, and the last 5 minutes it travels 8 kilometer. Here in this we can see that the distance is different and the time interval is same. This type of motion will be also called as non-uniform motion. Now at last the graphical representation is there, that we will do in the next video, and at last we will do that topic which I have left in the last video, that is of simple pendulum. Let us see simple pendulum. Next we will see simple pendulum. As I have made a diagram of simple pendulum, as we have seen simple pendulum in our clock, that pendulum runs, or you can say pendulum moves in a fixed path with a same amount of force. Suppose B is the initial point where pendulum is at rest. When pendulum starts moving, it will go to the left, again it will come back to the right. First pendulum will go like this, and again pendulum will come back in this direction. This type of motion is called periodic motion. There are certain terms which we have to study in this class. That is, first is length of pendulum. Length of pendulum means the length of pendulum, the wire, the string attached to the pendulum is called its length of pendulum. Second, we will see oscillation. Oscillation means the movement, oscillatory motion. Here when the pendulum will move, it will create an oscillatory motion like this. You can say like this. It is going like this, like in swing. First it will go like this, then again it will come like this, once left and again right. This is called oscillation. Third point is called amplitude. Amplitude means maximum displacement of oscillation. There is some maximum displacement. Suppose this is the bob. This bob, when it will go this side, it reaches the maximum height up to here. This will be the maximum displacement of the pendulum. That will be called as amplitude. The perpendicular height, or you can say the maximum height which a pendulum can reach is called its amplitude. Next, fourth term we will see frequency. Frequency, we can say that number of oscillation in 1 second. Number of oscillation in 1 second performed by the pendulum is called its frequency. Suppose one oscillation means when the pendulum will start, it will go this side, again it will come this side, then come back to the final position, that is equilibrium position. That will be called as one oscillation. One oscillation means pendulum starts moving from here, then again it will go this side, again it will come back. This center point will be called as equilibrium position, and the frequency means number of oscillation performed in 1 second is called frequency. Next, the last point we will see, that is time period. Time period means oscillation or you can say number of oscillation in one second, or you can say that is the frequency. Time period of one oscillation is called its time period. It means that how much time is taken by the bob to complete its one oscillation. We can say that time taken for one oscillation is called its time period. Hope that this topic is quite clear to you all. Next, we will see the next topic in the next video.